Okay, go. So this is just a video about the little thing that I'm sending along. This is the Whateverb, is what I'm calling it. It's a audio amplifier slash driver circuit for a transducer or a speaker, and then a preamp for a contact mic. So if you haven't watched the other video about experimenting with reamping and analog reverb alternatives, go ahead and watch that or look at it for a second, because it'll explain like the principles involved here, but how you can use it and why. But basically, I have this speaker transducer thing I made from the other video hooked up to the audio output right here, and I have a contact mic thing plugged in here, and I'm just playing music, and like just vibrates a little bit. You can put it on like stuff, and you know, whatever you want. I'm gonna switch things around because I only have one of these little cables. Then your piezo pickup just plugs into your speaker. Yep, there it is, working. And so then you just and now I'm going to show you how to put it together. Alright, so this is pretty quick build documentation for these boards that I'm going to be sending out. I'm just going to show you the different parts of it, how to put it together, so that you have no problems. So, starting out, we have the pickup. We're going to start with the amplifier over here. This is an LM386 amplifier. It's a common hobbyist amp circuit. It's directly off the data sheet. There's nothing weird about it. But LM386 right here. Before we go on, this is not how you're supposed to do the spring reverb driver circuit. This is dirty and quick, and yeah, it's perfect for experimentation, but if you're an audiophile, I would suggest you quit this video and never come back. Alright, so first you want to just put it in, and you see this little dot right here. The dot is where this little notch here needs to go, so you just put that in. Once you have the IC in, you can flip it over and kind of bend the legs down like this so it stays in. What else? Next, I would guess we should start with capacitors, since they're the biggest. See that big guy right here? It is a 220 to 470. I'm using 1000 because whatever. That'll just stick in there. We have two 10F 10 microfarads. Short leg goes to the negative. I'm kind of assuming a little bit of knowledge here, but you can always ask me questions. Short leg goes to negative. And if you don't know, you can just follow what I'm doing. Short leg here on the cap goes to the negative, the little pin labeled negative. Easy peasy, let's go. Alright, this is diode. It can be any sort of like Schottky diode, small signal diode. It's just for protection. That goes in there. 0.2, that's just input. It's just the input decoupling / high pass filter. Go there. Just got this little guy. This right here is a potentiometer for the input gain. I'm using a C1M. That is what I have. You can use a 100K. What else? audio input. This is an onboard audio input, so it's one of these little 3.5mm jacks, but you can just use the pins on here to wire it up to a panel jack if you want. But if you just put that in there, it should work. This is the first time I built this. I got these PCBs ordered, so there may be parts where I edit it and tell you how to fix parts. Yeah, because sometimes I have errors on my boards and it's fine. Yeah, so then you just flip it over and hopefully nothing. Oh, there's this filter thing, which I don't even know what that resistor is going to be. I'm going to leave it actually. This is a little low pass filter for the output for noise. I don't really care. I don't care about the noise in the reverb. I like noise. All right. Then we're just gonna solder. I'm using way too thick of solder right now. You can also solder as you go. I just like to solder it all at once. I hope this works. Okay, then you just go and you clip all the little leggies off, and they go flying. Yep. Okay, alright, cool. Yeah, right. This is the output to the spring reverb, or to the reverb, whatever, the speaker. I'm just gonna use these. These are little, you cannot see that, but these are like, these headers. They're like pin headers. So you just solder it in and it has a little hole that you can stick a wire in, but I'm just going to solder them here so that I can take things in and out. This is the power jack. It's just like a DC barrel jack using one of these. Cool. And then the way I do that is I just solder from the top here, like this. And hold it flat. Yeah. And then you can flip it over. Give it the old 1, 2, shoop-a-doop. All right. Okay. Yay, it works. Okay, so you just hook your positive end of your speaker to the positive, and then negative to ground, and this will turn the volume up. Turn your volume up. Cool. As you can see, it's, and that's because this phone is near it. But it's really loud. All right, now we have this side all built up. Everything's populated, it's working. This is how I recommend doing it, by the way, is testing it between. We can just start doing this side. So this side is based on, it's just a preamp for your contact mic or whatever pickup you're using on your reamp circuit. It's based on a CD4069. It's a little IC, yeah, it's very simple. So you just pop that in these holes. It's actually, honestly, kind of hard. You have to bend the legs just right so that they fit in. They don't automatically fit in. Yeah, and then it's just sitting in there. And then what else? We got our resistors. So we have a 470K, and you can actually replace this 470K with any high value resistor. The higher the value, the higher the gain of the preamp is going to be. I just picked 470 because it's kind of a medium gain, like just warm it up, you know, make it a little bit less piezo-y. And then we got our freaking 200. This is just a 200 ohm resistor, and that's just gonna go right there. that creates our little amp. And then we have a little capacitor here, 0.01 is what is on here. You can use 0.1, use anything, doesn't matter. It's a decoupling capacitor, little high pass filter. And then I sometimes will solder on the top to hold things in. You can do that if you want. Yeah, so the right here is the volume out. That's the volume output. You got the volume jack here, you have here. This is the output to like your speakers. So this is the main output. It's empty. I'll draw it there. Then you put the volume jack in. But also you want to charge that and then here's the anti-mic input that we're going to put a little header here so you can swap things out. Yeah, and then filter on. Cool. Pretty easy. Pretty easy. Careful with these slots with the chips. These can fry for various reasons. They probably won't eat all these charges. Yeah. Great. Let's just fly in here. Everything's good. Everything's good. Yes. Alright. Looks good. This is kind of wiggly, but whatever. Now we're going to test it out. Okay. So, I've taken, this is a little piezo disc. It's hooked up to my horrible studio speakers. Yeah, so the positive is going into the right. The ground is going into the left. We've got our volume here. Can't hear anything. Turn it up. Oh, you can hear it. Oh, you can hear it. It's even louder. Tell, but that is much more low end than you usually get a piezo directly into speakers. It's much richer, much less buzzy. It's just great. So this works perfectly. You shouldn't have to do anything to it. Right here, these pins right here, you can pop like a, I don't know, a little capacitor in there and see. This is all very unscientific, but depending on your power supply, you can just experiment with different types of capacitors here to filter the, because what's happening is the low, I'm gonna sound like a complete idiot, but this circuit is drawing off the main power supply, and you're hearing the noise in the power supply through this circuit. So it's not like actually contacting this output in any way, it's the noise generated from this circuit bleeding into the power supply of this one. So if you filter the power supply, it should provide enough stability so that you don't hear that anymore. Since I don't know the specifications of your power supply you're using, which can be anywhere from 9 to 12 volts, and if it's a noisy supply, you'll get more of that. Can't tell you what capacitor you use, but you can mess around with a small, like very small 0.1 microfarad might work. I don't know, but thank you for watching. Like and subscribe. One last thing about this is that I built this, or I designed this so that it could kind of be a freestanding experimentation kit thing. So you can use it sitting out in, it looks raw, but if your purpose is just to experiment with stuff, it'll be fine. But if you do want to put it inside of an enclosure, it's also set up to do that. You just basically you'll want to drill holes. You can just mount it on the panel, on a panel with these pots, and then have wires going to jacks from everything else. So instead of these, or in addition to these, you can wire the signal and ground to like a guitar cable, or a guitar jack, or a 3.5 mil, and then this wire the power and the ground to like one of these, panel mount power plugs, so that you can have it be inside of a little box, and maybe you have wires coming out for this, or maybe you're wiring it to a spring reverb. Either way, yeah, self-contained little thingy.